Hi, welcome to our lesson 7.9 on negative exponents, and the first two we are going to actually do first together, and these last five you are going to do on your own. So let's address the first two now. For our first rule of exponents, we have the definition of a negative exponent, and I want you to copy this rule down. And now we're going to consider a pattern to help us understand mathematically why this is the case. This part you don't have to copy down. So on the left side, we are successively dividing by 2. So 8 divided by 2 is 4, 4 divided by 2 is 2, and so on. And on the right, we have its representation with powers. And I want you to consider what you should fill in the question marks with to continue this pattern. So 1 is equal to 2 to the what power, and so on. Give you a minute to think about it, or more like 2 seconds. So hopefully you came up with this pattern. 1 is equal to 2 to the power of 0. 1/2 is equal to 2 to the power of negative 1. 1/4 is equal to 2 to the power of negative 2. And 1/8 is equal to 2 to the power of negative 3. So if you take this one, you'll notice that if you have 2 to the power of negative 1, it's the same as 1 over 2 raised to the power of 1. So we're just taking that negative exponent, putting in the denominator, or that whole power, and we rewrite it as a positive exponent. So go ahead and write this in your example box to the right of this definition. For our second definition, we have the following. Given a non-zero real number, any number that's raised to the power of 0 is equal to 1. So if you look back to the pattern that we had in the previous definition, we had 1 is equal to a to the power, we had 1 is equal to the power of 2 to 0. Now, one of the more common mistakes is that people assume that this equals 0, which is incorrect. Now, to prove this, let's say we have the following example. And please write this example in the example box. So if you have 2 raised to the power of 5 over 2 raised to the power of 5, when we simplify this, this is using the rules of rules of division, we simply subtract those exponents, and that equals 2 to the power of 0. Now, obviously, this whole thing does not equal 0. This equals 1. So anything raised to the power of 0 is equal to 1, or any non-zero real number. Now, the next part, what I want you to do is go to page 332 in your book, and in that page, you are going to copy down the rest of the rules for the chart that we had laid out, as well as their examples. So tomorrow we'll look to make sure that you have the complete chart written down in your notes. Now let's move ahead to just some practice problems to apply what we know about negative exponents and powers of 0. Let's start off super basic. So let's say we have 11 raised to the power of negative 2. What would that equal? Pause the video if you know it. Write it down. Well, this would equal 1 over 11 raised to the power of 2, which is 1 over 121. So that was our first practice problem. Now for practice problem number 2. I want you to go ahead and simplify this expression. 6 over 6 raised to the power of negative 2. And for this one, I want you to submit your response on the form. Make sure you have the work shown in your notes when we go over it tomorrow. And now this brings us to practice problem number 3. And for practice problem number 3, we have 4x with x raised to the power of negative 2, all raised to the power of 3. Now, one thing I want to emphasize, which I didn't emphasize earlier, is that when you have a negative exponent, anytime you have a positive number raised to any power that is positive or negative, you'll always have a positive value. So just because you have negative exponents does not mean that you're going to get a negative value. Okay, so let's now go ahead and simplify this. So since I have each of these parts raised to the power of 3, I'm going to rewrite it as 4 to the third times x to the power of negative 2 times, negative 2 times 3. So 4 to the third power is just equal to 64. And this is equal to negative 6. and we want to write this so that we have no negative exponents. So this whole thing equals 64 all over x to the power of 6. Now some people may have chosen to write this work this way. So this part you don't need to write down. But for example, in the parentheses, some people may have already done this so that they write negative 2 or x to the power of negative 2 as 1 over x to the power of 2. And then you can distribute that power of 3 to each part in your expression. Either way, at some point, anytime you have a negative exponent, you want to make sure that the negative exponent is always brought down to the denominator, if it's in the numerator, to get that, to rewrite that as a positive power. Okay, now this brings us to our last example, our last practice problem. And before we get into that, I wanted to share with you some world news. Cuba had their first high-speed internet connection activated. So for those of you that complain about really slow computers here, think about what it is everywhere else in the world in some places where they're just gaining high-speed internet access. In other words, lucky you. And for our fourth practice problem, I want you to complete this on your own. Go ahead and please simplify this expression and write your simplest form on the form. And so again, you are going to fill in the charts in your notes and submit 2 answers to the 2 practice problems onto the form, and also share the world news or write down what world news I had shared with you during the form or during the video. Have a good night. See you tomorrow.